Hello and welcome back to our channel. So today we are going to discuss a very interesting law. So this law is called Law of Periods, and this was given by Kepler, who worked on the data that was acquired for about 40 years. And this law was purely based on observations. We are going to prove this law based on Newton's law of universal gravitation. Let's focus on today's topic, that is about law of periods. If you have a planet that is orbiting a sun or a star, suppose the star is here and our planet is somewhere here. So we represent planet by P, the star by S, which is at the center. And now we will assume the simplest geometry. The orbit is circular and it is of size r. Let's suppose our planet has a mass m and our star has a big mass m. All right, let's do a force balance on our planet. Okay, so our planet will be attracted towards the sun or the star by a gravitational force. At the same time, it is also moving perpendicular to this force with the velocity v. Therefore, it will have a centrifugal force, mv square by r. The force of gravity that is holding or attracting this planet towards the star by g m by r square. Now this is equal to mv square by r. Okay, so if we now do a little bit of algebra, we can clearly see the velocity of the planet will be given by square root gm by r. Now this we also use in gravitation as our orbital velocity. If we know this velocity, we can easily calculate the time period. Okay, so the time period of complete revolution will be the distance, that is 2 pi r, divided by the velocity. Now using this simple kinematic equation, what do we arrive at? 2 pi r divided by gm by r, and we have to take a square root. Now if we rearrange this, okay, we can write the time period is 2 pi upon root gm, and here we will have r to the power 3 by 2. If you square this equation, if you take the square of this equation, I'm going to write it over here. This time period is going to be e square 4 pi divided by gm, and we have r cube. Right, so you can clearly see the time period square is directly proportional to the cube of the radius. And the constant of proportionality will represent the Kepler's constant as Ke is equal to 4 pi square by gm. We clearly see the equivalence between Kepler's law of orbit, which is E square is directly proportional to r cube, and this is obtained by using Newton's law of universal gravitation. Now I leave you with a puzzle. Which law was discovered first? Have a great day.